evening, guys. Welcome to Videos Academy Tutorial. Thanks for watching our videos online. Please subscribe. Please do press subscribe button and notification bell. That's our update on this YouTube channel. Thank you and God bless you. Amen. Today we'll be considering 2022 WAEC GCE chemistry practical under the topic called volumetric analysis. And here is the question to consider under volumetric analysis. The table below shows Burette reading obtained when 25 centimeter cube of solution of SOH containing 6.5 gram dm cube of solution was titrated with what? 0.06 mol per dm cube solution of H2SO4. Now, this is a table obtained when 25 centimeter cube of solution of SOH was titrated with what? Solution of what? H2SO4. So this is the table given to us, and this is particularly on what? On alternative to practical. That is, practical that has been practicalized and the result is given to you in order to what? Solve the question given after us. Now, here is a table here, and we are told that what? The equation for the reaction is 2XOH plus H2SO4 to give S2SO4 plus 2 water. Calculate the volume of acid used for each titer. We have to calculate the volume of acid used for each titer. This is the first titer, the second titer, and the third titer. Now, what are we going to do now? Just minus this one from this. So we have 0.624. So that's the first titer. The second titer is what? 0 minus 0, we have 0. 8 minus 6, we have 2. Then 48 minus 24, we have what? We have 8 minus 4 is 4. 4 minus 2 is what? 2. And the last one, we have what? 5 minus 5, we have 0. 5 minus 2, we have 3. 5 minus 1, we have what? 4. 5 minus 1, we have 4. And then we have 2 again. So that's the volume of acid use in each what? Titer. So we use 24.60, 24.20, and 24.30. Now, the next thing is to calculate the average titer value. Calculate the average titer value. Now, when I'm trying to calculate the average titer value, you need to put something in consideration, and that is the concordant values of your volume of acid use. You don't just use all the volume of an acid use, you use the concordant value. Concordant value means values that have the difference of what? Of 0.1 to 0.2, maximum difference of 0.1 to what? 0.2. Now, look at this very well. You can see that 24.20 and 24.30 has a difference of 0.1 compared to 24.60, which means that this is an outlier. This one is not concordant with these two values, because the difference between 24.20 and 24.60 is 0.4, and this one is what? The difference between this and this is what? 0.3. So this is an outlier, so we are not going to use this one in calculating our average volume of acid use, which is average titer. So because the difference between this and this is just 0.1, they are concordant values. Please note that concordant values are used in determining your what? Your average titer. So the average titer used now will be what? That's the one I've got. 2 average titer. Average titer value will now be what? Equal to the first, the what? The second and the third. The second and the third titer. The second and the third titer divided by what? 2. So which are 20 what? 24.20 plus 24.30 divided by what? 2. So 24.20 divided by what? 22.20, 24.20 plus what? 24.30 divided by 2. So that should give us what? So when we add it together, so we have what? 24.20 plus 24.30 divided by 2, we have what? 24.30 24.25 centimeter cube. Don't forget the unit is centimeter cube. So that's the volume, that is the average titer value or average volume of an acid used for this experiment. So now the next thing is to calculate the concentration of SOH in mole per dm cube. Calculate the what? The concentration of, that is B Roman figure 1, concentration of SOH in mole per dm cube. It's very, very important, this concentration, because we have two types of what? Concentration, gram per dm cube and mole per dm cube. So now we are asked to calculate the concentration of SOH in mole per dm cube, which is molar concentration, mole in 1 dm cube. So now, and the only way we can calculate the concentration of SOH in mole per dm cube is using the formula Ca over Va, Ca Va over Cb Vb equal to Na over what? Nb. So this is the best way of going about it. Why? Because this is unknown. This compound is unknown because of the what? Of the X element that is present. So now we have to use the standardization what? Formula, or we call it what? Carbon formula, to what? To solve for concentration of what? Of SOH in mole per dm cube. And SOH here is our B. Please note that SOH is our B because it contains hydroxide. So we usually use B to represent what? Base. That is B to represent the base because it contains hydroxide. And our A here is what? Is the H2SO4, which is our acid. H2SO4. Please note that B, we usually use B for what? Base. B for base, A for what? Acid. So now, meaning that what? We are looking for concentration of what? B is unknown here because our concentration of SOH in mole per dm cube is the concentration of base, which is CB. So now, and your VB is given from the question, which is 25.00 centimeter what? Cube. Your Ca is what? Is your average titer value. So which is what? 24. Your VA rather. Your VA is what? Average. Your VA here is average titer value, which is what? 24.25 centimeter what? Cube. Centimeter cube. And your Ca, please know that your Ca is given as what? Look at this, as 0.06 mole per dm cube. So you can see your Ca is also in mole per dm cube, and your Cb must also be in mole per what? Dm cube. So now, having done this now, what else do we need for this formula to be what? To be used? Now we have what? We need to get our Na. And our Na can be gotten from what? From the reactions. Look up, this is your A, this is your B. Your acid is your A, and your base is your B. And the coefficient of A here, of compound A here, is what we call what? Na. And your Na here is 1, because the coefficient here is 1. When you have nothing here, it means 1. Now, the coefficient of what? B here is 2, because there is 2 here. It's very, very clear that there is 2 there. So that is the what? Information that you need to use for this what? For this formula. Now, having got all these things now, then let's input everything. So your Ca is 0.06 multiplied by your Va, which is 24.25 all over Cb, which is what we are looking for, multiplied by your Vb, which is 25.00 equal to Na. What's your Na? 1 all over 2. So with this now, we can do as much to what? To cross multiply. And when you cross multiply, you have Cb equal to Now CB multiplied by CB times 25.00 times 1. 25.00 times 1, which is same thing as that, which is what, and also 2 times 0.06 multiplied by 24.25. Now, so let's do this one by one because of the calculator I'm using. 25.00 CB equal to now 2 times what? 2 times 0.06 times 24.25. So we have 2.91 here. So you divide both sides by 25.00 here. 25.00. So what am I having? Your CB now what? CB haven't divided that. Your CB will be what? Your CB will be, we have 0.1164 mole per dm cube. So you can approximate to 3 significant 0.116 mole per dm cube. So that's that about your what? Your value for CB. Now, I haven't got that. So what are the next things we are asked to what? Do? What is the next things that we are asked to do? So now, the next thing is to calculate your what? Your molar mass of XOH. Now, just let me read this one now. Molar mass of XOH. Now, to calculate the molar mass of XOH, we have to record that mass conc. We have to record that molar mass of molar mass. So let's first write. Okay, you have to record that mass concentration. Record that what? Mass concentration is equal to what? Molar concentration multiplied by molar what? Mass. Record that mass concentration, which is what? In gram per dm cube, is equal to molar concentration using what? Mole per dm cube. Mole per dm cube multiplied by what? Molar mass, which is in what? In gram per mole. Gram per mole. So now we have to calculate the molar mass now. The molar mass of SOH now will have the molar mass of SOH now. Molar mass of SOH will now be what? Mass conc of SOH all over what? Molar what? Molar conc. See? Molar conc. So molar mass will be called, by dividing both sides now, we have molar mass conc over SOH divided by what? Molar conc over what? SOH. Molar conc of SOH rather. So now, with this now, we can easily calculate our molar mass. So what's our mass conc of SOH? It has been given from the question. The mass conc of SOH is 6.5 gram per dm cube. Then this is 6.5 gram per dm cube. So, and the molar conc has been gotten as this. Please note that the mass conc is given from the question, which is what? 6.5. And the what? Molar conc is given from CB, which is what? 0.1164. So with this now, we can easily get our what? Our molar mass of SOH. So molar mass of what? SOH will be what? Molar mass of SOH is equal to, now you have 6.5 divided by 0.1164. So we have what? The molar mass to be what? The molar mass is 55.84. Don't forget, is in what? 65.84 gram per mole. That's the what? Gram per mole. So that's that about that, we have successfully calculated our what? Molar mass, which is what? 55.84 gram per mole. The next thing is to what? Is to calculate the atomic what? The atomic mass. Now I would like to what? Claim this area to calculate the rest of the what? The question. We have to calculate the what? The atomic mass of X. The atomic mass of X, which is the Roman figure 3. The atomic mass of what? The atomic mass of what? Of X. Now, the atomic mass of X can be obtained when you equate SOH to the molar mass. So, what do I mean by that? XOH is equal to your molar mass that we just got in, which is what? 55.84 gram per mole. Now, to get the atomic mass of X now, we say X plus, let's use this type of X, not to confuse ourselves, X plus 16, which is the atomic mass of what? Oxygen, plus 1, which is that of hydrogen. The atomic mass of oxygen is 16, atomic mass of hydrogen is 1. It will be given to you in the questions, equal to 55.84. So this one will be X plus 17 equal to 55.84. So by main transferring this now, we have X to be what? 55.84 minus what? 17. So what do you get from that? So 55 minus, okay, 55.84 minus 17. We have what? 38.84. So X is what? 38.84. So when you approximate this, which is AMU, when you approximate this is going to give you 39, which is what? Potassium. But we are not asked to identify it, we are just asked to what? To calculate the what? The atomic mass. So the atomic mass is 39 AMU, atomic mass units. So it is 39. So that is X for you, value of X. And the last question here says, name the suitable indicator for the titration. Now, the suitable indicator for this titration, Now, suitable indicator for titration, look at what? The reaction. The reaction is between SOH plus H2SO4 in this ratio anyway. Now, this is a strong what? This is a strong base. Why? Why is it a strong base? It contains what? OH, and it contains what? And this one is weak what? This is a strong acid rather. It's a strong acid because it also what? This H2SO4 is a strong acid, and anything that contains OH is a what? Is a strong base. So this is a what? A titration between strong base and strong acid. So whichever the indicator that you choose will be suitable for this experiment, because strong base versus what? Strong acid, any indicator is suitable. So if you write what? If you write methyl orange, you are correct. Methyl orange, you are correct. If you write what? Methyl red, you are still correct. If you write phenolphthalein, you are still correct. Phenolphthalein. So there are other indicators that we can also use, like what? You have what? You have the cresol. So, but these are the three major ones that is particular for this level. So that's that. We have come to the end of today's class. Please, you have to subscribe. Please do press subscribe button and notification bell as well as update on this YouTube channel. See you next time, and God bless you. Amen. Thank you.